Alright, welcome to video 16. This is 2.5 in the book, and this is on the topic of absolute value functions. So we're going to be graphing functions now that have absolute value in them. So absolute value from chapter 1, it's back. Let's look at one example first, the most basic one of all, this function right here. So instead of y equals x, now y equals the absolute value of x. How can I graph that? Simple. Just make a table. So I'm going to use the points -3, -2, -1, 0, 1, 2, and 3 for x. My writing got smaller, I apologize. Now if I plug in -3 into this function here, the absolute value of -3 is positive. Is positive 3. If I plug in -2 into this function, my value is positive 2. If -1 goes in, I get back 1. If 0 goes in, the absolute value of 0 is 0. If I plug in 1, the absolute value of 1 is still 1. The absolute value of 2 is still 2. And the absolute value of 3 is still 3. So I see my points now on a table. Let's go ahead and graph them. So I plot these points. So I'll plot -3, 3. That's right there. -2, 2 is right here. -1, 1 is right there. 0, 0, 1, 1, 2, 2, and 3, 3. So what you see here is that this makes a V-shaped graph. That's what absolute value functions will do. They'll make a V-shaped graph. Sometimes they'll point down if it's a negative absolute value, but here it's a regular old positive absolute value. So it points up in upward V motion, and that's where it goes. Like if I plugged in -6 for x, I get 6 back for y. So my point would be -1, 2, 3, 4, 5, 6, up 1, 2, 3, 4, 5. 6 would be right about here, which I didn't draw perfectly, but that's where it should be going. So that's the first example. Let's do a different one. So now I have y equals the absolute value of 2x, and that minus 3. So I'm going to again use the same points. I'm going to use -3 to +3. Just very simple points. That way we have some negatives, some positives, and 0. They're all usually easy numbers to plug in. So I plug in -3 in this function. So -3 times 2 becomes -6. The absolute value is 6, but minus 3 puts me back to 3. When I plug in -2, -2 times 2 is -4. The absolute value of that is 4. Take away 3, and you're at 1. When I plug in -1, 2 times -1 is -2. That absolute value is 2. Minus 3 gets you -1. If I plug in 0, the absolute value of 2 times 0 is 0. That's still 0. Minus 3, you get -3. By the way, do you notice that I keep going down by 2? Notice that's 2x now. That is related for a reason. That 2x means it's changing by 2 every time. Let's keep going. Plug in 1. 1 times 2 is 2. 2 minus 3 is -1. Oh, going back up now. And then plug in 2 into x. 2 times 2 is 4. The absolute value is still 4. Minus 3 gets you 1. Can you guess now what the next one's going to be? Plug in 3. 3 times 2 is 6. The absolute value is still 6. Minus 3, you get 3. So those are my points. So let's go ahead and graph this one. Here's my grid. I'm going to now plot all these points. Here we go. And poof. What you see is that I have a slightly steeper V than the last graph. Well, that too is the reason why. It's a little steeper now. So now if I just try my best to connect these dots. I'm on the iPad, so I can't get the exact points down, but I'm trying my best here. The graph looks something like that. By the way, those of you who are in geometry or had it last year, this point here, this is called the vertex. It's the corner point of the absolute value graph. So I do name that like a triangle. That's called the vertex. Okay, so one more graph and we'll be done. So now I have the function y equals negative of the absolute value of x plus 2. Which means, hint hint, all these answers for y will be negative because the negative's on the outside. So I'm going to again plug in those points, -3 to 3, get you some variety. negatives and positives, all that kind of stuff. So when I plug in negative 3 into x, negative 3 plus 2 is negative 1. The absolute value is 1. The negative, though, makes it negative 1. If I plug in 2, 2 plus 2 is 4. Sorry, negative 2. Negative 2 plus 2 is 0. Negative 0, still 0. I plug in negative 1 into x. Negative 1 plus 2 is 1. Absolute value is still 1, but the negative here makes that negative 1. I plug in 0 for x. 0 plus 2 is 2. The negative of that would be negative 2. If I plug in 1, it's negative 3. And hopefully now you see a pattern from here down by 1. So then I plug in 2, it's 4. The absolute value of that's 4. Negative makes it negative 4, and this becomes negative 5 when you plug it in. So what I see right now is I change directions right here. This is my vertex. This point right here. So let's graph that and we'll be done. So here it is, poof. So I've plotted all my points, and I have this little check mark looking thing here. But I know it's going to go in both directions the same. So this one I can connect on the right side of this. The right side of my vertex looks like this. When you graph this, you'll have a ruler and you'll do it nice. I'm just doing it by hand here. The left side looks like that. So I have a upside down V. Why is it upside down? This is Y right here. So again, that point, negative 2, 0, this point is your vertex. So that's a little introduction on absolute value equations. Just plug in a table of values and then plot those points, and you'll see where it's going. If you don't see the vertex, if you don't see it change directions like this, you don't see this going on when you graph it, you see a straight line, that means you didn't find your vertex. So then just plug in more points in your table until you find it, change directions. And then you'll have your vertex, graph each side of this equation, you'll be done. So we'll do more of this in class, but that's all I got for now. So hopefully you're done now for the weekend with your homework. If not, keep going. But anyways, I'll see you next week in class. Adios.